Hello, grade eights. Hope you are all well and you are keeping safe. I do apologize if I'm feeling a bit congested. I think I might be getting a little bit of the winter flu. It's not corona, I promise you. Um, so in the last lesson, you guys had to do quite a few activities in class. What this video is going to cover is or are the answers to those activities. So the first activity you had to do was Robo the Rat, which is on page 6 of your booklet. Um, it would be advisable. I want you to mark your work now. Just double check. Did you include liquid, solid, and gases during this whole maze on this little diagram? Were you able to identify those three phases, and did you use different colors? Because at the end of the day, he is trying to get to the cheese. So give a color for liquid, give a color for the solid, and give a color for the gas, and then just make sure you indicate that on each block that is in front of you. Check your mark everything. Pause this video if you need, if you have any questions, write those questions down, and then drop me a message if you need any help. So on page 7 of your booklet, you guys were meant to write in the definition of each of these substances, whether they were pure or not pure. Remember, a pure substance is a substance that consists of only one type of particle. So that would include an element and a compound. And then a substance that is not considered pure would be a mixture, and a mixture are two or more substances that are put together by physical means and not chemical means. So I have, once again, I've taken screenshots of the memo, and I'm going to chat to you about the examples that I would expect from you to put on this page. And I hope you've written in pencil and make sure that you've marked everything. The first one is a pure substance, and the book gives you two examples of a pure substance, that is hydrogen and neon. So if you had given any other element, you would have gotten this right. Any other element is considered a pure substance under pure substance. So please double check your answers. If you didn't use an actual element, if you used a substance in maybe a real life example, then just ask me, send a message to either myself or Mr. Ginsberg, and we will check to see that you have got this right. Then for a compound, now remember, guys, the compound is when two or more elements are chemically bonded. There was a change. There was a reaction, a chemical reaction. And because of that, now a new substance has formed. So the examples that the book gives you is water and hydrochloric acid. You could give any other compound that you can think of, at least 2 or 3 different compounds. So the ones we have here are magnesium oxide, I've got silver nitrate, I've got potassium iodide, and sodium chloride, which is table salt. You all should know what table salt is. I would prefer that you actually give me a chemical compound and not a compound from the real world, or something that you Googled an example, real life examples of a compound. I would prefer a chemical compound that is relatable to lab practice. So please just double check your answer there. At the bottom of the page, you'll see there is two pictures of a particle diagram or a molecule diagram. And as you can see, the first one is water. I've got oxygen and I've got hydrogen, and that is the Mickey Mouse. And remember, I've said to you before, please, 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 the Mickey Mouse is, you need to know that off by heart when it comes to water. The second one is hydrogen chloride, also known as hydrochloric acid. And there's one line between the hydrogen and the chlorine. That one line represents the one bond between hydrogen and chlorine. And what's happening there is that the hydrogen and the chlorine are sharing electrons, and therefore they have bonded in a covalent way. So we are moving on to mixtures now. Now remember, mixtures is something that is not chemically bonded. There's a physical, they've been physically put together, but it's like a salad. Think of a salad, all those different ingredients that have been put together, but they are not there's no chemical bond. Okay, so the examples that we've put in here are ones of chemical compounds that are in the same solution. So the two that the book gave was neon and hydrogen. So just because they're in the same solvent or the same solution doesn't mean that they're chemically bonded. Then we have potassium iodide and sodium chloride. We have also water and magnesium oxide. So different compounds can exist in the same volume of a substance, but it doesn't mean that they are bonded. So we have used chemical compounds to show you that they are, yes, they're in close proximity, they're close together, the molecules are close together, but they're not bonded. No chemical change has happened between those two compounds. Then number 4 is a molecule. I had a lot of kids, not a lot, but a few kids were asking me, what is the difference between a molecule and a pure substance, or a molecule and a compound? Now remember, guys, you can have a molecule of a compound, you can have a molecule of an element. Think of diatomic molecules. They are elements that exist as two atoms. So O2, N2, I2, your diatomic molecules, they exist as two atoms, two atom elements. A molecule, the molecule example here is that I could have a molecule of water, I could have a molecule of oxygen, a molecule of potassium iodide, a molecule of hydrogen, or a molecule of hydrochloric acid. I could have a molecule of water and a molecule of sodium chloride in a mixture. That doesn't mean that there's a bond there, although water does assist in the breakdown of salt. The last one is number 5. Number 5 is showing a crystal lattice. Now, crystal lattice is a symmetrical 3D arrangement of atoms inside a solid. An example of this are any of your solid salts. Your solid salts are going to be crystal lattices. So it's going to be sodium chloride. Another example of this would be your carbon allotrope. So now an allotrope is how an element exists in a different form. So diamond, as in the diamonds that they mine, it's made out of carbon. It's just that carbon atoms are arranged in a different format and in a different number. Graphite is a form of carbon, and it's just been arranged in a different way and a different ratio of carbon bonds. We'll get to that a little bit later in your high school science. But for now, I just want to make sure that you understand the basics and that you've marked your work. Once again, grade 8s, if you get stuck, please drop me a message or speak to Mr. Ginsberg. So the last thing that you guys had to do was page 8. It was a particle diagram. You guys had to look at the particle picture and then actually identify whether something was a solid or a gas, a pure substance or mixture, an element or compound, or if it was an atom, a molecule, or a crystal lattice. Now, there's a lot of overlap all these definitions, on all these key phrases. So don't worry if you think they are both, or there are two options that are applicable. That's actually quite normal to start thinking along those lines. But let's go through the particle pictures and see, and hopefully you guys are marking and see how you do. So the first one I think I gave to you in the last video. The second one, okay, let's just look at the particle picture now. So this particular picture is all 3 circles have got the same pattern. So that means that it's a pure substance because all 3 are the same. They are spread out, they are dispersed, which means that when it comes to our phases of matter, what do we remember grade 8? That when it's dispersed, it means it's a gas. When they are closer together, chances are it's a liquid. And then when they are closely compacted and they are very, very regimented and solid, then that is obviously a solid. So in this one, it's going to be a gas. I think it's helium gas, actually. A pure substance It's definitely an element and it's atoms. Because if it was a compound, it would have two different colors, and if it was a crystal lattice, it would be arranged in a 3D symmetrical pattern. The third one shows two circles that are bonded together and they are dispersed. So first things first, grade 8, that's a gas. It's definitely a pure substance because it's only one type of particle there. There isn't a different color. It's an element and it's a molecule. Why is it a molecule? Because it's more than one atom, more than one atom. So this would be a diatomic molecule. So it would be an element, one of those special elements that are in group 7 of your periodic table. The fourth diagram shows a Mickey Mouse. So before you even had to look anywhere, you would know that this is water. Water, in this situation, it's going to be gas. And remember, water can be in gaseous phase if there is extreme heat. It's a pure substance, so it's a compound, but it's a pure substance because it's only one type of particle or one type of molecule. It's a compound because there are two different circles there, and it is a molecule because it is more than one circle. I think it's the fifth image. You will see that there are two different patterns there, and they are quite compactly placed together. So I'm going to go with a solid. It's definitely it's going to be a mixture, even though they're closely packed together. It's a mixture, but there isn't a actual how can I put this? There isn't a regimented pattern. It's actually all over the place. It's a compound and it is a crystal lattice, okay, because it is regular, but there's no bonding. Then we have, although I must say, grade 8s, I would argue that that could be a pure substance, to be honest. But just put it as a mixture for now. Then we have the sixth little picture. You've got two different types of gases happening here. They're dispersed. They're not. There's definitely a diatomic molecule there, so an element, and then there is another element. So there's two elements that are existing in this space. It's a gas. It is a mixture. Why? Because those elements are not bonded together. Now, if that stripy pattern was attached to the diatomic molecule, 100% compound, but it's not. It's two times, so you can see Mr. Ginsburg has written there, two time elements. Okay, two elements that are existing within a space. And then for your atoms, molecules, and crystal lattice, the one is an atom, a pure elemental atom, and the other one is a molecule. So it's an atom and it's a molecule. Okay. The last one is definitely a solid. You should all be comfortable with this now. It's a mixture and it is a compound and it's a crystal lattice. So please mark your work, double check that you understand all of this, and we will go on to the next video.